morning to everybody. Dobre jutro. This is the third day of the second Grabchenko International Conference on Advanced Manufacturing Processes, InterPartner-2020. This year conference edition is very special. It is proceed online. The virtual room for the conference is provided by the Sumy University of Technology, but our host university is Odessa University of Technology. Good morning to everybody once again. I am chair for the first session today, which is dedicated to production planning. We have the four presentations, which I hope for every listener very interesting, because they are dealing with various aspects of the quantity approach, mainly to the process of planning. Especially one of the issue which is widely presented is the decision support for the maintenance or for the business model, etc. So let me introduce the first presentation. It's an intelligent predictive decision support system for maintenance service provider. The presenter will be Professor Katarzyna Antosz from Rzeszów University of Technology of Poland. Good morning again. Dzień dobry. So I should say the web is yours. Please follow the rule that we have 10 to 12 maybe minutes for each presentation to make a room for any discussion or question. Okay, you are welcome.
Okay. Thank you very much. Good morning, everyone. As I was introduced, my name is Katarzyna Antosz. I'm from Rzeszów University of Technology, and I would like to present the paper Intelligent Support System for the Maintenance Service Provider. The co-author of this presentation is Małgorzata Jasiulewicz-Kaczmarek from Poznań University of Technology. Okay, next slide, please. A maintenance process of internal vehicle transport is important from the production companies and also from the service providers. Failures of transport vehicles for the production companies mean difficulties in the realization of production and also for supporting processes. Failure of the transport for the service organization means those employees of the organization are assigned to carry out of service activities for a longer period of time. This issue can be a particular problem especially for the maintenance service providers. That's why in order to plan the maintenance activities, it is appropriate to predict failures to prevent them by undertaking adequate preventive actions. Next slide, please. Moreover, there are some problems and challenges that we can observe in maintenance service providers. The first one is continuity of operation of the process. Ensuring the continuity of the operation of the processes carried out by the clients of the maintenance company and their success depends mainly on the efficiency of functioning machines, devices, and means of transport. The second problem is the need to coordinate the dates of maintenance activities. The main problem of managers of service providers include the need to coordinate the dates of planned maintenance activities, for example, inspections, and unplanned activities related to fixing the failures at customers' facilities located in the different places. Moreover, the third problem is machines from different manufacturers. Service technicians often struggle with maintaining machines from different manufacturers, which forces them to comply with various control procedures and service principles. Another challenge is machine criticality, because machine criticality is the key element for both the company and maintenance service providers. For example, the same machine can be categorized as critical in one enterprises, but not in another. So another challenge after determining the maintenance strategy is the adjustment for the frequency of preventive work according to the criticality and technical condition of machines. So what's more, planning is a decision-making process that deals with the allocation of resources to jobs, to given time intervals, and the task to optimize one or more goals. Next slide, please. Although the literature of the subject presents some solutions supporting maintenance process, especially for the vehicular maintenance machines, there is still lack of dedicated, simple, low-cost and intelligent solution, especially for small service providers. That's why the main research of the problem is, although the literature is how to support the maintenance service providers, in planning their maintenance task based on the criticality of vehicles and predict adequate maintenance activities, especially in the small service providers. So next slide, please. The case study presented in the paper is based on the real data from the two service providers. To gain the main research of the problem, the research task was as follows. First one, the collection the data from the maintenance process of internal vehicle transport undertaken by service organization. The second one, the calculation of risk of failures for internal vehicle transport based on the data collected from the service providers. We used here the risk-based maintenance. And the third one, the last one, task was develop the decision support system with the fuzzy logic. Next slide, please. As I told, this data were collected in the real service organization provider. So we have to classify this data. We used 3 criteria of classification. First one was type of internal vehicle transport, then the model. The third one was age and the working time. So on the box plot, box plot shows on the figure 1 is the value distribution of 2 parameters, age and working time. As we can see, the ranges were for age was the vehicle transport from 7 to 22, and the working time was almost 30,000 working hours. As we can see on the box plot on working time, that we can see the outliers. We had no influence for further analysis. Next slide, please. The first step of the study was to identify the type and the frequency of maintenance activities. Mainly the type of activities was divided into two categories. First one, the planned and unplanned activities. To identify the frequency of maintenance activities, we used 2 criteria, age and working time, and we divided this criteria in 3 categories, low, medium, and high. It depends because of the value of age and working time. To identify the 3 categories, we use our experience as a researcher and also the literature and also the experience of maintenance service providers. To analyze the maintenance activities, we use the MFE indicator. So to calculate this MFE indicator, we use the number of maintenance activities in every category, and also we use the number of all activities according to all interval vehicle transport. Next slide, please. The table 2 shows the obtained results from value of MFE indicator in each category. And in the table 3, we can see the risk level of MFE indicator. Having also the experience and information from the literature, we decided to divide the level of MFET in 3 categories, also for low, medium, and high. When risk indicator is lower than 0.10, we can identify this MFE indicator as low, medium when the value was in the range of 0.10 to 0.20, and high when the value was of more than 0.20. In the table 4, you can see the risk matrix according to tables 2 and tables 3. So we can see the levels of risk failures in every category and every group of internal vehicle transport. And analyzing this risk matrix, we can see that it's very easy to identify the risk when we have the value of age and working time in the middle of the ranges. But it's very hard. We can make a very easy mistake when this value is in the border, in the ranges of this, in the border of the ranges. So we decided to use fuzzy logic to design the decision support system to support the maintenance service provider. Next slide, please. And the next it could be used. So figure 2 shows the proposed for us for this data fuzzy interest system, and figure 3 the designer of fuzzy interest system. This system has two inputs. First one is age, and the second one is working time. We use MAM dummy system, and the output is value of MF indicator, which is very important for the maintenance service provider. Next slide, please. We use different membership functions for outputs and inputs. For inputs for age and working time, we use Gaussian membership functions, but for outputs, we use the triangle membership functions. We established this function based on the data we collected. So age and working time was Gaussian, and MF indicator was triangle membership functions. Okay, next slide, please. We used our risk matrix presented on the table 4 to identify the rules for this interface fuzzy system. As we can see, we identified 9 rules. According to this matrix, we implement these rules in our decision support system. Next slide, please. On the figure 7 and 8, we can see the results of our system. So using this system is easy to calculate, to analyze the MF indicator. For example, on the with figure 7, we can see the calculation of MF indicator when we have age equals 7 and working time equals 7,000 hours. So the MF indicator is 0.96, sorry, according to a corresponding linguistic value presented in the table 3, so the risk level is high. It is a very important information for the service company because in the next step, he can analyze and identify the right maintenance activities, for example, the preventive maintenance activities. Of course, having this information, we can analyze using different values of age and working time. We can analyze in every time the value of MFA indicator. So the next slide, please. And some conclusions. So we presented very simple decision support system with fuzzy logic. Of course, we can use different new technologies like sensors or RFID to implement the service, and we will do in the next future. The last slide, please. Sorry. Thank you for your attention.
Thank you very much for your presentation. We have a little drop of the signal, but it works still okay. Do we have any questions from the auditory, from the for the presentation? Okay, so that's a good tradition to have a question from the chair. So it's a very interesting approach you used because you limited all of the possible data sources and informations about the machines, limited to 2 in fact, data. The one, as you presented entirely in presentation, was the working time of the machine and the age time of the machine. Did you try to find any other dimensions or criteria which will be useful for your model?
As we know from the maintenance service provider, the other matter could be experience of the operator, because even we have old machine. Yeah. Sometimes when you have new operator, it's mostly depends the failures of this machine. The same is in the new machine. When you have new machine, when you have a new operator, it's very important to have good qualification for this machine. But of course, we try to use another signals. We will put some sensors on our chosen machines, and we will see how much data we can collect and analyze and put these parameters and the inputs of our system. But this paper is just the first step. We just want to prepare very, very good system. We just use these two parameters, age and working time, for the start, because we want to see if such system will work. This system now is implemented in the two service providers, and yes, it's a good solution. They say it's a good solution, but we have to improve the system.
Yes,
to use, of course, another data. Yes. So.
Okay. So the next question is, you mentioned about the data which are supplied by the company. Nowadays, we have a system of the fleet management, which is, as far as I can recognize, mainly based on the cloud computing. And I think it's a very promising perspective for your approach, because you can create implementation which is also supplied by the cloud. So
our idea is using online data from the machines, from the sensors, so to see how the parameters can change during the working time of the machine. So this is our idea in the future, but we need to do a lot to have this very good system.
The classical approach to describe the maintenance strategy is based on nowadays four steps: the reactive, preventive, predictive, and you probably on the predictive level, because you have
it's mainly on the predictive level, but to design the system we have to use the data also from the preventive and reactive maintenance, because especially from the data from above the failures. Yes, it's typical for the reactive maintenance.
Yes. So when you switch to the cloud, it's possible using the IoT systems to be in the perspective mode.
Right.
Thank you very much. It was very interesting and very promising for the practice of management.
Yes, I think we will see the results, the next results of the system in the next conference, InterPartner conference. So
I will be looking for.
Okay. Thank you very much. Thank you very much. And greetings from the sunny Rzeszów one more time. Thank you, and see you face to face, not online. Thank you very much.
Thank you very much. The next presentation will be conducted by Maksymillian Madziel. Maksymillian Madziel. That's the joint article of Dorota Stadnicka and Maksymillian Madziel from Rzeszów University of Technology. Maksymillian is ready, I hope. The web is yours.
I'm ready. Yes, thank you very much for the introduction. So welcome to everybody. So I led myself to repeat my name. I am Maksymillian Madziel, and together with Professor Dorota Stadnicka, we work at Rzeszów University of Technology in Poland. And we prepared the presentation concerning application of lean analysis and computer simulation in the complex product manufacturing process. So I'd like to say up front that performance of the manufacturing process depends on different factors. Among others, the following can be distinguished: raw material quality, manufacturing process quality, workers availability, machines availability, work organizations, etc. If a company, for example, would like to improve the performance, has to undertake adequate actions. For example, it realizes Six Sigma projects. This can help with the identification of the problems and the possible further elimination. Sometimes such methods as quality analysis with the use of A3 report or material and information flow with the use of value stream mapping, as well as other lean tool applications, can be enough. But sometimes more sophisticated tools as simulations are indispensable. In this work, please move to the second slide. And the next one, please. In this work, CSV map, being a result of value stream mapping, is used to create a simulation model. The presented manufacturing process realizes a complex product, therefore the manufacturing system is complex as well. On the basis of data concerning the manufacturing system, a simulation model was developed. The problem which appeared in the development process and the ways of the elimination are presented in the presentation. The simulation model was used to perform simulation with chosen sets of data. The results of simulation were compared with the results of lean analysis. The research goal was to discuss how the simulation can help in the analysis of a manufacturing system where a complex product is realized. Please move to the fourth slides. The work is divided into two parts. First part concerns lean analysis, where low performance of manufacturing line is described. Different factors influence manufacturing line different factors actually influence manufacturing line performance. In this analysis, the following factors are analyzed: machine availability, takt time, and number of employees. The case study company would like to deliver to a customer 20 packs of ready products per day. Therefore, a set of analyses needed to be performed to find out under which circumstances the goal can be achieved. The second research goal actually concerns development of the simulation model, which can be useful in the analysis and which can be applied in performing simulation for the case study of the manufacturing line. Please, next slide. The previous one, please. Yes, thank you. Duration of each process of analyzed manufacturing line is presented in table 1. The analyzed manufacturing process consists of 19 processes which are realized in the company as well as by cooperators. Availability of the workstation machines realizing the manufacturing processes are presented in the table 1 together with information concerning processing time and the number of employees realizing the processes. Each workstations work for 2 shifts. Available working time for a shift equals 27,000 seconds, which means 8 hours. Real available working time is lower because the chosen workstations machines availability is decreased. The processes which are not shown in the table, which are process 3, 6, 15 and 18, are realized by cooperators. Transport between the manufacturing company and cooperators is currently realized once a day. However, because the cooperators are situated close to the manufacturing company, the transport can be realized more often. 2 employees are involved in each of the following processes, process 17 and 19. In each of the other processes, only 1 employee works. Next slide. And the takt time was calculated according to the first equation, and actually the calculations are below. So the second equations, the equation shows the calculations, and please move to the next slide. Because of decreased availability, the processes do not work in the same pace, which is expected to be equal to 2,700 seconds. If a customer orders 20 products per day and the company works for 2 shifts per day. Current cycle times of the processes were compared to the maximum cycle times for the processes with decreased availability, expected to ensure on-time deliveries, and this is shown in figure 1. From the data presented in the figure 1, it can be concluded that the problem exists for 3 processes, process 5, 17 and 19. In the simple analysis, the company decided to add additional employees to the process 17 and 19 and implemented training and standardization in process 5. Thus, the situation on the manufacturing line has changed, and from figure 2, we can see that the problem was solved. There are no bottlenecks processes anymore. Therefore, according to the perform analysis, the goal of 20 packs per day should be achieved. Please, the next slide. Based on the lean analysis, the simulation experiment was performed and the following factors were applied. Process availability, which could be 100% or lower, batch size, which equaled 1 packs or 4 packs, and way of cooperation with external service providers. Transport between the company and external service providers might be realized few times a day. The cooperators can provide services up to 60 packs per day. The factories of the external service providers are situated close to the manufacturing company. Please, the next slide. And actually, on this slide, we can see the simulation model. The simulation model was developed in the FlexSim software, and this was done based on the manufacturing process structure, which is presented in Figure 3. The processes which are realized by cooperators, these processes are process 3, 6, 15, and 18, were treated as 1 day of waiting. Data from table 1 were used in the simulation model. Only data for process 5, 17, and 19 are different because some changes were made by the company. Moreover, it was assumed that input material components are always available, which means that the problem of delivery delays was not analyzed in the frame of this work. The next slide, please. Tables 2 and 3 present a simulation plan data. In scenario 1, if only one component, in scenario 1, one component is when one component is ready, is sent to collaborators. In scenario 2, the number of pieces sent in one transport to collaborators is 4 packs actually. In scenarios 3 and 4, the number of pieces increased to 16 packs, and it seems that the most reasonable solution is sending at once 20 packs of products, which is the target number for the process to manufacture. In other scenarios, the number of pieces sent to external service providers is even higher. In the planned scenarios, the number of products sent to collaborators ranged from 1 to 26. It was as an author's intention to see if increasing the number of packs would affect manufacturing line performance. In scenario 1, 6, and 8, one piece flow is simulated. In other scenario, the batch size was increased to 4 packs. In scenarios 1 to 3 and 5, it was assumed that availability equals 100% for all processes. In other scenarios, availability was decreased for chosen processes. Details concerning scenarios in which availability is decreased are presented in table 3, together with available working time for the workstations, machines with different levels of availability. In all scenarios, the inventories between processes have no limits. Moreover, the materials and components are always available. Furthermore, a simplification concerning assigning one employee to each process was applied. And the next slide, please. The results of the performed simulations are presented in table 4. The simulations were continued for 6 weeks, it means 30 days. Only in scenario 1, additionally 4 weeks, it means 20 days period was applied. Times for manufacturing line takt time and lead time for scenarios where batching were considered refers for a whole batch, and throughput was multiplied by the number of products in batch. Figure 5 is a graphical presentation of manufacturing line takt times comparison for different scenarios and with takt time. The takt time depends on customer requirements. If the customer expects 20 products per day, it means that takt time will equal 2,700 seconds. If the processed cycle time or manufacturing line takt time is lower than takt time, it means that the process is able to manufacture the expected number of products. In all presented scenarios, manufacturing line takt times are lower than takt times. Therefore, the simulation confirmed that conclusions drawn on the basis of the analysis presented earlier in the work. However, the throughput is taken under analysis, and it can be seen that only in case of scenario 1, it was possible to manufacture the expected number of products, which is 600 packs in 6 weeks, which gives 20 packs per day. In this case, one-piece flow has been implemented. It can be also noticed that in 4 weeks, it was impossible to manufacture the expected number of products. And to summarize, it has to be said that analyses which are presented in the first part of the paper are not enough to understand whether the manufacturing system is able to deliver the certain number of products. And please move to the next slide. And to summarize everything, conclusions. On the base of the presented work, it can be concluded that for analysis of a complex product manufacturing system, value stream mapping and simple analysis can be not enough. Therefore, in such cases, it is recommended to implement computer simulations. From the simulations, such outputs as throughput, lead time, and number of products manufactured in a fixed time can be easily found out. From the presented case studies, it's clear that the decreased machines and workstation availability will influence the process efficiency. The same situation refers to the number of products sent to collaborators in one transport. In the future work, the simulation model will be, of course, improved. Moreover, in the future research simulation experiment, according to a plan which will allow to identify influence of predetermined factors of manufacturing line, takt times, lead time, and throughput will be performed. Thank you very much for your attention.
Thank you very much for your presentation. Do we have any questions from the auditory, from the listeners online? Okay, let me say a couple of words about my impression after your presentation. The first is that that's the pretty well example of how to use the computer, the modern tools as Flexim is, or any other kind of such software, as any logic or Simio. It's a well example of how to prototype the processes with the simulation, because in fact you have done a couple of simulations, a series of simulations to present and prove the kind of heuristic search for the proper solution. The question is it possible to employ the optimization methods in this case? I think about the optimization module which is present in Flexim software.
Yes, of course. Flexim has implemented optimization tool, and it's called Experimenter. So you can actually optimize everything which is analyzed in the model. Okay,
and the second question is because it seems to me from the presentation that the simulation was based on deterministic data. It's no stochastic processes in this simulation. I'm wrong, or am I wrong, or I missed something?
So actually the data was implemented from the other article, and the data was actually from, this was actually real data from the factory, and based on value stream map, the data were imported to the Flexim.
Okay. Thank you very much for your presentation and for the article. Thank you again. And now we should start with the third presentation of this session, which is, as I was informed by the Vice Chair of the conference, Professor Vitaly Ivanov. It will be presented as an offline presentation with the web system. I mean, it will be the video clip. So please start with the
grain is supplied to port terminals by
presentation.
Dear the conference participants. First, we thank the organizers and management of the conference who provide the opportunity to take part in this incredible event. My name is Vladyslav Shramenko. Research results are presented to your attention according to the next theme. Rationalization of grain cargo transshipment in containers at port terminals.
Sorry, I didn't say anything about the presenter.
The grain market is actively developing in Ukraine. The grain is exported mainly through ports.
Okay.
The grain is supplied to port terminals by
yes, okay. So it's too late. Too late.
However, there is an insufficient efficient organization of cereals cargo turnover in grain supply chains from grain elevators to ports. One of the reasons for inefficient logistics is insufficient load carrying possibilities that are caused by limited quantities of specialized rolling stock, railway wagon for grain trucks for grain delivery, and also its irrational use. Excessive rolling stock idle at terminals leads not only to increased cost over the entire logistics chain, but also to increased time of vehicle turnover. Failures at seaports can cause undesirable wave effects that negatively affect transport network operation in wholes, as well as economic and social aspects. For port infrastructure and management structure should also facilitate effectiveness use of port resources, railway carriage and vehicles. Optimization of the container transshipment process at the port will reduce the cost of grain delivery. The study aim is the mathematical formalization of grain cargo transshipment process in containers at port terminals using a multimodal delivery system. Research tasks: to analyze container cargo supply dynamics in Ukraine in railway and water transport, including grain transportation. To analyze the alternative technologies for transshipment of containerized cargo. To create an efficiency criterion for process assessment of container cargo transshipment in ports. To formalize port terminal costs associated with container cargo transshipment using alternative technologies. Research tasks can be determined and solved when the system approach methods of analysis and synthesis, statistical analysis, tools of economic and mathematical modeling were used. The annual volume of cargo transshipment exceeds 160 million tons for the first time at 13 active Ukrainian ports in 2019. Maximum indicators were recorded for grain cargo transshipment in Ukrainian seaports in 2019. Container transportation took third place among cargo in 2019 and first time during the last 10 years exceeded the volume of 1 million TEU transshipment. The largest influence was provided by the Ukrainian agriculture sector into record transshipment of cargo seaports in 2019. Coordination between grain elevators, terminals, carriers, ports, and all participants must be improved during cargo delivery. This will help to increase the efficiency of multimodal transportation and also to optimize technological process in ports when railway carriages will be unloaded. The analysis was carried out for reloading containers process at ports according to alternative technologies. Container cargo transshipment according to the direct option railway carriage ship. Container cargo transshipment according to option railway carriage warehouse ship. Technology features are the next of container cargo transshipment according to the direct option railway carriage ship. Long idle time of railway carriage waiting for cargo transshipment to ship. Excessive of normative waiting time for cargo transshipment. As a consequence, time wagon turnover will be increasing, and therefore it's necessary to increase railway carriage fleet. The need to coordinate and schedule compliance of railway carriage to arrive a group of wagons for cargo reloading into the ship. The necessity to form a technological route from railway stations of departure to destination ports, which conditions of further containers transshipment from arriving railway carriages to one ship. Technology facilities are the next for container cargo transshipment according to option railway carriage warehouse ship. Limited container terminal area. Probability of waiting in queue for transshipment to warehouse. If containers will be temporary storage of containers at port terminals, then cargo owners will get additional supply chain costs. Additional loading and unloading related to storage and storing of containers. Increased probability of damage to containers during handling and storage operations. Efficiency criterion includes, in case of container transshipment according to direct option railway carriage ship, the next parameters. Cost of arriving and departure of cargo mini train to from the transshipment place according to direct option railway carriage ship. Cost associated with an idle time of railway carriage shunting locomotive and container waiting for transshipment to ship. Costs of container transshipment from railway carriages to ship at departure ports. The efficiency criterion includes the next parameters during container transshipment through warehouse at port. Costs for arriving and departure of cargo mini train to the place of container transshipment from railway carriage to warehouse. Cost associated with an idle time of railway carriage shunting locomotive and container waiting for transshipment to warehouse at port. Costs associated with container searching in warehouses at the departure port. Costs for transshipment through warehouses to ship at the department port. Costs associated with the debt capital. Analytical dependencies have been obtained for certain components of costs for transshipment containers in ports according to the direct option railway carriage ship and reloading containers through warehouses as an analysis result of technologies. The next conclusions are received as a result of the performed research. There are disadvantages in ports such as incoordinations in operation between different transport kinds during goods transshipment under the direct option, failure to achieve a normative idle time under the performance of cargo operations according to direct technology and through warehouses. The efficiency criterion was designed for transshipment process of containers with cargo at the port terminal. This is total specific costs associated with cargo transshipment in containers at port terminals. Analytical dependencies were obtained from certain components of costs related to containers overloading according to railway carriage ship technology and containers transshipments of through warehouses as a result of the analysis of technologies. The mathematical formalization of the process of grain cargo transshipment in containers at the seaport, which is proposed, will contribute on designing mathematical models and on formation of rational technologies for container transshipment in the port. Our contacts for questions and recommendations are provided on the slide. Thank you for your attention.
Wait a minute. Okay. I have some problems with. Okay, I hope I can be hearing now. So this was another experience for us in the time of the web conferences. There are only one question as far as I noticed from the YouTube. It will be sent to the presenter and the answer will be probably given personally by him. In my opinion, it is a very interesting mathematical proof of efficiency of multimodal transportation. So for the supporting and proving the decision which will be conducted in the future, it's a very convenient. Okay, and now let me introduce the fourth and the last presenter in this session, Mariusz Salwin from Faculty of Production Engineering, Warsaw University of Technology, Poland. His presentation is titled Product Service System, New Opportunity for Printing Industry. You're welcome. Web is yours.
Thank you. Good morning. Thank you for introduction, dear professor. Can you hear me?
Yes, of course.
Okay, thank you.
Right.
My name is Mariusz Salwin from Warsaw University of Technology, Poland. I am going to present a paper, Product Service System, New Opportunity for Printing Industry. Can I please, next slide? Product service system is a concept developed in Scandinavia. It's a special case of servicization. It's a combination of products and services. Product service system focuses on the meeting customer needs. We have three main types of PSS. It's product oriented, use oriented, and results oriented, and PSS is also environmental friendly solution. So can I please next slide? The aim of this paper is develop a product service system model for the printing sector. We formulated two research questions. First was what are the possibilities of using PSS in printing industry? And second, what benefits can PSS bring to manufacturer, machine, and customer, its printing house, and environmental. So please next. Research methodology adopted of this paper was the four main phases, steps. First was literature review. Second was printing sector analysis, company survey, and construction PSS model. I will develop these 4 steps on next slides. So can I please next? First was analysis PSS models in industry. We use some database and searched the term PS product service system in industry or its synonyms. We found around 50 works, and on the table you can see the most popular PSS models used in industry. We selected we can if you find we couldn't find PSS for printing industry. So in next steps, next slide please. We analyzed product service system design method. We also use some research science database and searched for the term product service system design on synonyms, and we found around 60 PSS design method, and we also couldn't find a PSS design method for printing industry. If you see this figure, the most popular is PSS design for mechanical engineering, and also some the analysis of these cases. One method for PSS design, you can use 2 or more sectors. So next slide please. Next we analyzed printing industry. So printing industry is important sector of the economy Poland and also Europe Union. In Europe Union there are 120,000 printing houses, and in employing around 80,000 people. The printing products include books, labels, newspapers, packages, billboards, leaflets. So the printing sector is also printing machines. The printing machines are the main element of printing houses. Equipment, they are used to print on an industrial scale. At present, the main manufacturer offer on the market special printing machines in various variants of equipment together with basic services, installation, maintenance, and trainings. Can I please next slide? In next step in our research, we concluded industrial workshops in the printing house. On the workshop, we used some tools: Pareto, Lawrence analysis, brainstorming, and survey. We analyzed that company of flexographic printing with long tradition. The company cooperate with companies from another sector: pharmacy, chemistry, food, and cosmetics. This company specializes in the production of labels and laminators. In first step, Can I please next slide? So in the first step, we use Pareto-Lorenz analysis. We found the problems that generate costs, and in 2080, the case of the rebuilding of the printing machines, printer failures and stoppages, waste problem, disposal, material losses, and trainings. So we use based on this research, I think it's next slide, please. Okay, thank you. Based on a Pareto-Lorenz analysis, we using brainstorming and consultation with employing and management board, and developed questionnaire survey. This questionnaire survey included the services that's the best for this company. The services we divided into three main groups: machine-related services, printing process, and additional services. We conducted the survey among all printing house employers. So the results are presented on the table. You can see some of the services were chosen by the same company's employees on the various level of this company. So on these workshops, we identified the main needs of the related to the following areas. So first was trainings. So in this company, sometimes printer don't know what to do, or have problem with printing machines, how use these printing machines. And next was the printing process. The printing process is very complicated, so it's a problem with section and mixing of the ink, cleaning this printing equipment, and another. Next was waste management problem, because if you ink or paint or another stuff used in printing doesn't environmental friendly. So it's important that printing house have good waste management system. So please next. Okay, next, because okay, so in this slide you can see the main three packages services divided in 6 groups, and this is we use approach based on PSS, that is services customized to the printing house, analyzed printing house, and the main can I see next slide? Okay, thank you. On this figure, you can see product service model for printing house. We using approach based on PSS philosophy. So in this case, manufacturer has ownership for printing house. This manufacturer earns money at the same time from the production and printing machine services. Print the customer that this is printing house focus on based or core business that is printing and find new customer, and this is approach based on PSS philosophy, and we wanted find the best customized solution for this company. Thank you.
Thank you very much. This is a very interesting case of the business model innovation related to the Industry 4.0 concept we discussed yesterday on the keynote session. So it's very valuable that you have the access to real.
You understand me.
Yes, of course. I hope the listeners are satisfied. So thank you very much. Is there any plan to implement this business model in the company, which, as I can see, cooperates in creating this article also?
Yes, we publishing our research in another also another journal. I can send you paper, and then we can.
Okay. So
it's it's because we analyze it all printing sector in Poland.
Okay.
So I can. I think it's too long describe.
Okay. So thank you very much. Time is up for our session. The next session will be just next minute. Thank you very much for the organizers to give me opportunity to be an active supporter for the third date of the conference. Thank you for to all the participants for their presentations. See you in Odessa next year. Thank you very much.
Okay, thank you very much. Good morning, dear ladies and gentlemen. It's my pleasure to welcome you at the next session devoted to the topic advanced materials. And as the first speaker, I would like to invite Mykola Melnichuk. Mykola Melnichuk comes from Ukraine, Lutsk National Technical University, and he is the co-author of the paper Thermomechanical Properties and Pearlite Composites. They have prepared it together with Mikhailo Potejchuk, Vitaly Kashitsky, Marcin Sosnowski, and Serhiy Kucik. And one of the majority of the authors comes from Lutsk, and there is also author from Poland, from Uniwersytet Humanistyczno-Przyrodni Jana Długosza w Częstochowie. So, Mykola, please, stage is yours to start your presentation.
Good morning, Dagmar. Good morning, dear colleagues. Let me introduce myself. Thank you for introducing Dagmar. I am head of Department Material Science at Lutsk National Technical University. And the beginning of my speech, I would like to say thank you a lot for the conference team for excellent organization of this meeting, this conference, and the opportunity for discussion with colleagues. And also in this very strange time, I wish to all participants stay healthy and success work. Let's begin my presentation. The global building thermal insulation size was estimated as more than $30 billion in 2020, and is expected to expand at compound annual growth rate to 4.8% next year. Increasing residential and commercial application of the product to reduce the overall energy cost, coupled with rising awareness about energy conservation, is expected to drive growth. Please, next slide, if possible. Next slide. Okay, thank you. The environmental impact of insulation material is likely to shift the industry focus focus on the development of environmental friendly product over the forecast period. Besides, increasing price of plastic foam are expected to harm the industry growth, thereby leading to the development of alternative product. Perlite is widely used of loose fill insulation, usually in mock masonry construction, because of the following qualities that make it desirable: low toxicity. According to the Perlite Institute, no test result or information indicated that perlite poses any health risk. Other insulators, such as asbestos, vermiculite, which may contain asbestos, and fiberglass, are more dangerous. Chemical inertness, meaning it will not corrode beating electrical and communication conduit. Perlite has around 7 pH, which is similar to fresh water. Perlite is very resistant to temperature change, temperature application for plus 800 grados Celsius degree. Biological proof is not exposed to decomposition and decay by microorganisms, is not favorable environment for insects and rodents. Due to its unique physical and technical properties, explain perlite is widely used of effective heat insulator. It is the most widely used in construction. Expand perlite is fireproof, does not and is not destroyed. The leader in the production of perlite and in product of perlite is USA. Where about 7 million of this product in produced every year. What about Ukraine situation of it? Since 1960, in Fogosh perlite deposit, Transcarpathian region has been operating in Ukraine with reserves of 13 million tons in Ukraine. Perlite is mainly used of backfill in pour from about 30% in the production of dry cement, mortar or gypsum, binder by Knauf company and Henkel and etc. The analysis of foreign and domestic experience in the use of perlite shows that in addition to the traditional spheres and applications, this material, known both in Ukrainian and abroad, have been developing a new direction perlite products, such a block of various shapes and size, lightweight insulation, perlite plates, etc. The most of patented monolithic composite are filled with perlite based on mineral powder binders, like cement. There is some limited published work devoted to the study of monolithic thermal insulation material by perlite with other types of binders, and there is practically no information of the study of perlite from Ukrainian deposits, which have their unique chemical composition and properties. Of the basic of the above, it is possible to formulate the task of the study, our study, which is to determine the optimal composition, the method of formation of monolithic materials filled with perlite, and to establish the relationship between composition, method, and manufacture physical and mechanical properties. Please, next slide. Thank you. Our research methodology. The surface were studied for optical, digital, microscope, and microstructure, and thermoperlite were studied for scanning electron microscope. Please, next slide. Experiment of development of the optimal composition of the material were carried out using a second order simple lattice plan (SHAFET). The standard physical and mechanical parameters for thermal insulation material according for standard. Study of compressive strength and flexile were performed by known method of study of building materials. We can see of this slide. Please, next slide. Measuring water absorption and thermal conductivity. The sample were examined to water absorption and material according of standard is to measuring the mass of water adsorbed by simple to dry material partly immersed in water for a certain time. And thermal conductivity was studied by method of simulation. The sample is placed between the heater and cooling medium. Please, next slide. As the result of mathematical planning, optimal composition ratio were obtained by 5 composition whose property were investigated empirically. The average values of spatial density of the different composition show of this table. Of this chart, the component were added of following order. Firstly, the plasticizer was mixed, but binder was gradually mixed mechanically with perlite. The test piece were formed in the metal form. We can see of this figure, this slide. Further, the composition were compressed and sintered in the temperature range from 600 to 800 for 1 to 2 hours. Please, on this slide, we can see a result of measuring water absorption by weight. Comparing the results that were reported in literature, it can be observed that water absorption decreased on average by 20%. This is due to the decrease in the number of open pores, possibly due to pressing and sintering at temperature up to 800. But the absorption of water by perlite is still quite high, and the material absorbs a low of water up to 68%. Therefore, the product where possible contact with water, the matter requires hydrophobization by the surface layer, which will significantly reduce the water absorption. Okay, please, next slide. Can be seen visually that the number of surface pores increasing with the decrease the amount of binder from position from 5 to 1 number. Inclusion of dark color particle of graphite powder which was used as a non-stick layer in metallical form. Shows the result. Please, I'm sorry. Can number of surface pores increase with decrease the amount binder? Please, next slide. The result of electronic microscopy shown of the slide, it can be seen that all the composite test pieces have a homogeneous structure and evenly distribute perlite particularly in the matrix. However, cavities are observed in composition number 1 and 3 and show in this figure. Obviously, this was due to insufficient binder being to completely wet the filler. As a result, cavities of up to 400 micrometers in size. Accordingly, such cavity dimension are stress, concentration, and significantly weaken the matrix, which correlate well with the result of the mechanical characteristic study. In sample number 3, the pores of the border of the filler matrix are smaller and more evenly distribute across the section of the sample. The sample number 5 contains the least amount of defects due to its high liquid glass content and extrusion. Further study need to establish a relationship between cell pressure and quantity of pore. Please, next slide. Next slide, please. According to result of the strange study, with increasing binder contents, the composite strength is almost linearly increasing, which provides the matrix of the formation of strong interface bond between the matrix and the filler. All compositions have sufficient strength not only as thermal insulation, lining matrix, but also structure material. In particular, the composition number 5 with standards, the load corresponding to the strength such as of the bricks brands M150. Please, next slide. The coefficient of the thermal conductivity increases with the increase in the composition in the proportion of liquid glass with an logical because not only in the decrease in the amount of perlite in the composition, which provide low thermal conductivity, but also the decrease in the number of internal air pores, which consistent with increase in the special density of the test PS. Please, next slide. Finally is conclusion. We can see of that slide our conclusion. It's optimal composition in the number 3 because that which contains optimal perlite. Okay, thank you. I finished my presentation.
Thank you very much, Mikola, for your inspiring presentation. I think it is really worth to put the emphasis that you was dealing with environmentally friendly product and putting focus on low toxicity and any health risk. And at this moment, I would like to give the space for questions. Are there any questions for Mikola? If not, very shortly, I will give you a question. What are the further major challenges for near future, in your opinion?
Okay. No question?
Mikola, can you tell us what are further major challenges for near future?
Excuse me, can you repeat your question? I hear badly your question.
Okay, my question is, what are next major challenges for near future in your research?
Yes, we of course we will be working in this topic. We must make material more less absorption water and need some experience to okay.
Okay, thank you very much. Are there any questions? If not yet, okay. Thank you very much once more for your presentation.
Thank you. Thank you, Dagmar.
Thank you, Mikola. All the best. And at this moment, I would like to invite further speaker. I suppose that it will be Oleg Zabolotny with the paper Methods of Evaluating the Wear Resistance of the Contact Surfaces of Rolling Bearings. This is the paper in collaboration with Lutsk National Technical University, Ukraine, and Slovak University of Technology in Bratislava, Slovak Republic. And the further authors are Konstantin Svirželsky, Anatoly Tkachuk, Valenty Zabolotsky, and Dagmar Cagaňová. So, Oleg, please, you are invited to share your presentation with us. Or Anatoly Tkachuk? Okay, Anatoly. Okay, thank you, Anatoly. So you are welcome to share the presentation.
Good morning, ladies and gentlemen. We bring to your attention a report of the topic Methods of Evaluating the Wear Resistance of the Contact Surface of Rolling Bearings. In modern condition of mechanical engineering, we development high priority is given to experimental and material science aspects of assessing of wear resistance of conclusions frictions surface. which consists of the selection of materials which hide wear resistance characteristics. Increasing the durability of congruent mechanical parts is impossible without the creation of modern engineering methods for calculation wear resistance, which would take into account the physical and mechanical characteristics of friction parts. Modern tool operation lower the angular velocity, external friction conditions, environment, lubrication, and future friction exist methods of the mathematical description of wear of graduated mechanical parts can be divided into groups. The first group based off physical and mechanical laws of wear, taking into account the the wear process. The second based on analysis of quantitative characteristics in wear without physical process. Where analytical expressions that describe the wear process but do not fully reflect all aspects of the wear process due to the inability of take into account the special of contact of different technical methods. Next slide, please. Slide 3. In this slide, we can view to confirm of the tribotechnical assumptions used the tribological mechanical of durability test. According to the kinematic features of all installations for tribotechnical testing for materials divides into classes. And the next slide, the Aldeming relatives displacement. Next slide, please. Slide 4. The main characteristic of evolution tribotechnical characteristic are where intensivity, where resistance criterion and friction coefficient is the criterion mechanical friction laws, the ratio of as a ratio of friction force to the value normal force. The intensivity of the ratio of the thickness of the discretion materials via to the part of friction. Slide 4, 5 and slide 7 show the materials apparatus for determining the wear resistance of friction parts. Next slide, please. And slide 7. The slide shows the materials apparatus for determining the wear resistance of friction parts. Next slide. Slide 8. Investigation of wear process and determination of run-in period wear performance of the VNIP installation. The 707 series roller bearing, still 100 from 6. Hardness SRC 6062 might to different finishing technologies which microstructure materials which carbides we use as samples. Next slide, please. Slide 8. It would be fair to say that there is the same chip removal process as the abrasive process. The only difference is that machining is processed by a cutting tool which controls geometry determines approach. And to the stretched surface, the regular place in of the same size. On pass is removed one layer of sheet. Plastics approach. Next slide, please. An example of about Firestone curves obtained by the above methods. Next slide, please. Thank you. For each of the 5 grades of purity, 10 identical samples were taken which were tested in installation needs of for 16 minutes and 18 hours. A total of 15 control points. We objected the location, which is some figure. The nomogram shows that the developed as were durability during of the burn in a period of the surface layer roundless. Its H max is expanded of all H max value by a line that interested the ordinate axis above of the origin point. The dependent of where on the during of test for all grades of surface layer purity is same. Next slide, please. The proposed dynamic calculation is based on the analysis of the mechanism of the process destruction of parts under different type and modes of friction and allow used to obtain approximative rate of various materials and their interface. The value of this method also lies in the fact that based on the calculated data, it is possible to lay the foundation of the sphere resistance of friction pairs at the descent state. It was found that the any amount of wear increases sharply during the first 16 minutes, 3 hours, and then growth slow down. The burn is area when the micro-rollers of the machining its foot is slow inside 11. Its mate is red and shaded. In this area where largely dependent of the burn in time, if the radial load is very high and does not depend on microgeometry of the contention surface. Then mathematical description of the phenomenon is carried out based on the results of processing data updated during operation. The process method for analyzing the resistance of the made surface of parts to ensure the maximum duration of the period of stable operation by assuming technological models of mechanical processing in confirmed by experimental data and can be used in the design of the technological process for manufacturing parts. It is planned to develop a technology for machining the parts of the balance, which will minimize the working period. This allows the machines to be operated immediately at the right modes, bypassing the running in period. Next slide, please. Thank you. The literature search used to organize the research and show on the slide. Next slide. The report is complete. Thank you for attention.
Anatoly, thank you very much for your presentation. At this moment, I would like to ask, are there any questions? In the meantime, you can think about the questions. I would like to express thanks for presenting the proposed method for analyzing the wear resistance, which can be used in the design of technological processes for manufacturing parts. Are there any questions?
No questions.
Okay, if no questions, thank you once more for presenting, and we can continue with the following one presentation. The following presentation has the title Simulation Permeable Porous Materials of the Complex Shape During Radial Isostatic Compression. This paper was prepared in the collaboration of two Ukrainian universities, Lutsk National Technical University and National University of Food Technology. And the authors of the paper are Alexander Povstianoy, Anatoly Mikhailov, Natalia Imbirovich, Oksana Dubinska, and Halina Herasimchuk. So we are going to listen to the following presentation. I suppose that the presenter of this speech will be Anatoly Mikhailov, and Anatoly Mikhailov comes from National University of Food Technology in Ukraine. Please, Anatoly, stage is yours. You can start with your presentation.
Нет, тот же самый. Good morning. Good morning. My name is Anatoly Mikhailov. Сейчас. Good morning. My name is Anatoly Mikhailov. Good morning. Anatoly Mikhailov. Thank you very much for the opportunity to take part in your conference. I'm ready to start my presentation. The topic of my presentation is simulation of compaction of porous permeable materials of complex shape during radial isostatic compression. Next slide. Sorry. Powder metallurgy demonstrates the advantages that allow you to obtain materials with the best or with all new properties to produce products in the most cost-effective way. These products include porous permeable materials, PPM. The choice of optimal parameters for the process of creating porous permeable materials is a complex and important task of modern efficient production. PPMs are widely used in various branches of modern industry. In particular, they are used as filters of cleaning liquids and gases. A promising method for producing filtered element is radial isostatic pressing of powders. The method allows you to produce long products of simple and complex shapes with a uniform distribution of porosity. Compaction of the powder occurs under the influence of an elastic element. Next slide. At present, the issue of modeling powder compaction in complex forms, namely in radial isostatic pressing, is not fully investigated and studied. The purpose of this work is to study the influence of the radial isostatic compression scheme on the regularities of compaction and form change of the filter element, which has a complex shape in the form of a flask using computer modeling. Next slide. Choosing the optimal parameters for the pressing process is a difficult task. That is, along with traditional research methods, the method of preliminary computer modeling is now being used more and more widely. This was made possible due to significant progress in understanding the main features of the behavior of powder materials in the process of compaction and the creation of appropriate mathematical models. Next slide. The simulation is based on a continuum approach. The relations of the theory of plasticity of a porous body were used as determining relations. The most suitable for pressing elastic shells made of polyurethane, which can withstand multiple deformations at pressures up to 600 MPa. Next slide. Figure 1 shows form for pressing filter with spherical basin. The powder is compacted by elastic elements. Next slide. For comparison and analysis of the finished product, two sealing schemes were considered, radial and axial. The powder material, which is compacted, powder will still BBS 15. The initial porosity of the filter element was 0.7. The compaction occurred on the mandrel under the influence of elastic environment, the material of which is polyurethane. Next slide. Due to the symmetry, half of the axial section was considered in the simulation. The surface of the polyurethane on which the force load was applied moved at the constant speed in the radial or in the axial direction. Next slide. Figure 3 shows that no. Page 9. Figure 3 shows the distribution of porosity and accumulated plastic deformation under radial compression. At the initial moment, the wall of the filter element is compacted. The distribution of porosity along the radius of the filter wall is uneven. As the radius increases, the porosity increases. The maximum value of accumulated deformation is in the inner surface of the filter wall, and the minimum value is in the outer surface. Next slide. Figure 4 shows the distribution of porosity and accumulated plastic deformation under axial compression. The powder is most intensively compacted in the area of the bottom of the filter. The distribution of porosity along the bottom radius is uneven. As the radius increases, the porosity increases. Next slide. Figure 4 shows result of porosity distribution and accumulated plastic deformation under axial compression. Next slide. The distribution of porosity along the wall height is uneven. In the lower and upper parts, the porosity is higher. Compaction of the powder in the wall area under axial loading occurs to a lesser extent. In the regard, a radial compaction scheme was considered, in which the powder was compacted in the radial direction. Next slide. The simulation results are shown in figure 6, 7, and 8. Figure 8 shows that the density of the filter wall is higher. Next slide. Figure 9 shows the structure ppm in the form of flasks, which is obtained from a powder PBS 15. Next slide. When pressing a powder filter in a form of a flask, the distribution of the values of porosity and accumulated plastic deformation over the volume of the product is uneven and depends on the sealing scheme. When the load is applied radially, the material is compacted more intensively in the area of the filter wall. The bottom of the filter is less compacted. In the case of using the axial load scheme, there is a more intensive increase in the sealing of the filter bottom. The filter wall is also compacted, but less intensively. The use of a scheme in which the powder is first compacted in the radial and then in the axial direction makes it possible to obtain a more uniform distribution of the cost and accumulated plastic deformation. Next slide. The main results of this work is implemented in production at the Lutz place of activity of state-owned enterprise, Supersquid and LLC work trade for cleaning technical liquids and fuels from mechanical contamination. Next slide. This slide shows references. Next slide. Thank you for your attention. I wish you good luck and creative success.
Dear Anatoly, Mikhailo, let me express my thanks for your effort and for your presentation about simulation permeable porous materials. As I do not see any question in the chat, is there any question? No, I didn't find any question at this moment in the chat. And also, during the shortage of the time, I would like to invite the last speaker within this session, Advanced Materials, who is Pavlo Vouk, and he's also co-author with his colleague, Ivan Chayun, and both are from Odessa National Polytechnic University in Ukraine. And the title of their presentation is Strength Calculation Method for Steel Wire Rope Considering Broken Wires. So, Pavlo, the stage is yours. You can start your presentation.
Hello, dear Dagmar. Hello, dear colleagues. I want to present the article named Optimization of Steel Wire Rope Strength based on load capacity considering broken wire. In course of use, the rope is continuously run out. As a result, some wires become broken. The presence of such breaks in the wires is the normal operation condition of the wire rope. As we know, the presence of wire breaks significantly affects to the load capacity of the rope. The safety of rope operation is achieved by applying the appropriate rejection standards. Is according with these standards, the use of the rope stops if the number of wire breakages at the lay step reach a certain value. In different countries, the rejection standards are different, but we should note that так, I'm sorry. Yes. I'm sorry for this mistake. Hello, Dagmar. Hello, colleagues. I want to present the article Optimization of Steel Wire Rope Strength based on load capacity considering broken wire. In course of use, the rope is continuously worn out. As a result, some wires become broken. The presence of such breaks is a normal operation condition of the wire rope. As we know, the presence of wire breaks significantly affects to the loading capacity of the rope. The safety of exploitation of the rope achieved by applying the appropriate rejection standards. In accordance with these standards, the use of ropes stops if the number of wire breakages at the lay step reach a certain value. In different countries, the rejection standards are different, but сейчас меня не слышно. Не очень нехорошая связь. In different countries, the rejection standards are different, but we should note that these rejection standards determined without any analytical study of the effect of wire breakages. Next slide, please. The purpose of our work is to build an analytical model for determining the loading capacity of the rope, which takes into account the effect of broken wires. Also, to build this model, it is necessary to determine the magnitude of the frictional forces that act on the wires in rope. Next, please. Thanks. In nowadays, the calculation of the rope for static strength is carried out according to Formula 1. In this formula, S is the maximum axial force, N is the safety factor, PC is the aggregate breaking strength of wires, which is defined as the product of the cross-sectional area of wires by the value of their ultimate strength. The last parameter is the coefficient K. This parameter considering everything that make distinction between wire rope and a group of wires. It includes angle of twisting, it includes some stress, some twisting strength, and other parameters. In our work, the coefficient K is determined based on a study of elastoplastic deformation of wires. The calculation uses a model of elastoplastic deformation with linear hardening. Also, when we determine the coefficient K, we taking into account wire breakage. This calculation model was built for a pure stretch of the rope. Next slide, please. For this purpose, we solved two problems. The first problem regards friction of a helically formed wire against a cylinder having a straight generatrix. The second one focuses on the friction of wire against the surface of a cylinder having a helically formed generatrix. Next slide, please. Thanks. Let's consider the solution of first. The calculation scheme is shown on figure 1. This problem is similar to Euler problem. The difference is that in this task the wire is not concentrically located on the surface of the cylinder, but along a helical line. On the basis of the calculation scheme on figure 1, we built the equilibrium equation of element ds. Show next slide, please. Thanks. When we solve this equation, we obtain formulas 11 and 12. These formulas determine the magnitude of friction force that act to a broken wire. This solution can be applied only for single lay ropes. Next slide, please. Next slide, please. Thanks. The solution of second problem is similar. The second problem was solved for double layer ropes. The difference between first and second task is that the wire located on the surface of a cylinder with a helical generatrix. This solution differs from the first one also by taking account of a twisting angle of strand in wire rope. Formula 15, next slide please. Formulas 15 and 16 are common for two tasks. Next slide, please. Based on obtained formulas, the friction force of a wire in a single and double laid rope depends on the wire tensile force, friction coefficient, lay angles, and the length of contact between wire and cylinder. Next slide, please. We use this solution to determine the contribution of broken wires in a load capacity of a rope. The calculation scheme of this task is shown on figure 5. The participation of dangling wires in a loading capacity of rope is determined through the drop of loading capacity. Next slide, please. Thanks. The loading capacity of rope with wire branches determined by formulas 18 and 19. Based on this study, we determine the coefficients K for single and double lay ropes. Next slide, please. This coefficient we can see on formula 21, 22, and 23. Next slide, please. Next slide, please. Thanks. This table shows a comparison of the experimental and theoretical values of loading capacity for a double layer rope with an organic core. The error between experimental and theoretical data does not exceed about 13%. Next slide, please. Thanks. Next slide, please. Thanks. This study was carried out for pure stretching. But we think this method is applicable to take into account the effect of broken wires for other loading schemes, free stretching or bending on the drum and other. Thank you for your attention. That's all.
Dear Paolo, thank you very much for your presentation.
Thank you.
I think it was really good job you have done with strength calculation method, which you was able to share with us. My question is, do you have any plans for your research in the near future?
Yes. We want to make experiments to determine the friction coefficient we want to adopt this calculation method for other loading schemes, for free stretching of a rope, for bending of a drum, and others.
Okay, thanks for sharing your plans with us.
Thank you.
Are there any other questions? I have looked to the chat. At this moment, I do not see, but I think that we are exactly in time. So really exactly. So finally, let me summarize that we had a chance to listen to the presenters like Mikola Melnichuk, Anatoly Tkachuk, Anatoly Mikhailov, and Pavlovo, who shared with us their research and prepared papers on topics on advanced materials. So finally, thank you very much for all your contributions to this session. And I also wish good luck to the following session with the title Quality Assurance, which will follow us. So good luck to the conference. Thanks for your presentations and enjoy the conference.
Секунду. Все. Можно починати? Can I start? Thank you. It's okay. Good morning, ladies and gentlemen, participants of conference, dear colleagues. We are starting now work of session number 5. I'm the session 5 chair. First, let me introduce myself. Alexander Grabchenko, Doctor of Technical Science, Professor of Odessa National Polytechnical University. At the beginning of our work, I would like to say a few words about the importance of the topics of the session for modern industry. Product question. Product quality is the main factor determining its demand in the modern world. Unfortunately, we often deal with low quality products. Absence of quality, failures of parts, machines, and mechanisms can lead to serious accidents. So, the necessity of quality assurance is obvious. It will be 2 presentations at this section work. First presentation, automate attestation of metric for industrial robots manipulation system, will be presented. This work from Zhytomyr Polytechnical State University, and the oral speaker Anton Kravchuk. And the second presentation, standardization limits of test methods for engineering nanotechnologies. The Sumy State University, and oral speaker Konstantin Dyadura. So the first presentation, Anton Kravchuk, are you ready?
Yes, I do.
Please, you can start. Some words. about time. I remind the speakers about the need to comply with the timetable. Up to 20 minutes for report, for presentation, and up to 3 minutes for question. Please.
Greetings.
Can start.
I'm happy to participate in InterPartner conference, and it's a big honor. So let's start. Next slide, please. So let's start from the base. There are robotic technologies used widely in all over the world, and it's used in different factories, manufacturers, and other. And in general, the statistics saying that the annual production of and implementation of industrial robotics increasing in average by 15% every year. So industrial robots do a lot of different work and different tasks, and they face several problems. For example, in a stage of planning, for example, of placement or programming or other. And our major challenges are to solve a certain problems of this task. Next slide, please. So our aim is to develop a new approach to identify the technological capabilities of industrial robots by conducting the automated industrial robots manipulated system metric attestations. And we have following tests. So they are to prove the importance of performing the attestation, to develop the methods of the attestation of industrial robots, to do research for industrial robots matrix attestation, and to collect obtained results and analyze it. Next slide, please. So, in general, our methods consist of 3 main stages, and each stage consists of 2 steps. So, the first step is to create a 3D model of industrial robot, and the following step, step number 4, is download this model to the special software, what is called RobotDK. The stage number 2 starts from adjusting and implementation of these elements of these 3D models in this software, and stage number 4 is choosing the finite element of the industrial robot. And by finite element, our main idea is a gripper or instrument. Stage number 3 is finish stage, and we have 2 steps here. Step number 5 is a procedure of attestation, which consists of step-by-step methodology. And step number 6 is collecting all obtained results and the visualization. Next slide, please. So let's get closer to the step number 1. If we are talking about creation of a 3D model of industrial robot, we can do it in special CAD software, such as SolidWorks, or either we can use official 3D models. So we can download it and use in our research. The second step is to download these models, these elements, components, to the software called RobotDK. It's procedure step by step, and the step number 3 is to fix these elements, to adjust them, to give some parameters. And step number 4, it's choosing a finite element. We choose a gripper or instrument. Next slide, please. So it's a small slide about step 4. In this case, we talk about 2 causes, 2 main conditions of research. First, we can do research without any object of manipulation, And another, we can do research with object of manipulation. And by meaning of object manipulation, we can say that it can be a detail, a tube. In this case, it's a small cube. And it's determined by H parameter. And this H parameter is generally the full length of object manipulation and a gripper. And one more interesting thing is that in this case we take into account the orientation of this whole construction. From the left you can see it's a horizontal orientation, and from the right it's a vertical orientation of the gripper with object of manipulation. Next slide, please. So, step number 5 is a procedure of attestation, and this procedure of attestation is very complicated. It's step by step, and when we are doing this procedure, we can adjust the different parameters. We can see all information, we collect this information, and later we analyze it. And when all information, all results we got, we work with it, we got a 3D model, you can see it on step 6, of work area. And this 3D model of this work area is main result of whole procedure. So the main task is to determine work areas in which gripper of industrial robot maintain a certain orientation with object manipulation or without it. Next slide. So after a few months of research, we got some results, and in this slide the results are present as sections or slices of 3D model of work area, and from the left you can see the results of horizontal of vertical orientated gripper, and from the right you can see the result of horizontal orientated gripper. And as you can see, the results are quite different. The size, the form, and the area of these slices, these sections, are quite different. Next slide, please. As a finished result of this, we have a 3D visualization. And 3D visualization gives us one more very important parameter. It's allocation of these zones near the industrial robot. So you can see the real sizes, real form, and real location of these zones where the robot maintains certain orientation. In this case, it's vertical orientation without object manipulation. Next slide, please. Very similar results we got of metric attestation with object of manipulation. So the form are quite similar, but the size and area of these results are smaller, and the location of these work areas are different. Next slide, please. So here we have a 3D visualization of metric attestation of industrial robot with object manipulation, and we can see that the results are quite similar to the previous one, but they are a little smaller. Next slide, please. And the full view of all results, the full view of all information of all results we obtain, we can see here, and we can compare these results. And as you can see, the work area without object of manipulation is quite bigger, and with object manipulation is smaller. These forms are different, their location are different, but one interesting moment is that in some cases the work area cross each other. and this is a very interesting moment. We want to do our future research in this forward. So next slide, please. And our conclusions are next. So a new approach to identify the technological capabilities of industrial robots is proposed, and the necessity of error matrix attestation is proved, which is important and necessary as a priori information while designing mechanical assembling at the stage of placement and planning. A step-by-step methods of industrial robot matrix attestation is developed, the content of which is the determination of geometrical parameters of certain orientations of industrial robot structural element H. Procedure of matrix attestation for brass robot model is done, and the results of the proposed approach of industrial robot metric attestation are generalized and allowed to solve a certain technological problems of industrial robots. For example, planning or placement technological equipment in the industrial robot workspace. So thank you for your attention. If you have any questions, I will be happy to answer.
Thank you very much. Please, questions to speaker. I have a question. As I can understand from your slides, you are investigate an industrial robots for automated or semi-automated assembly. Are you using in your research system of technical viewing for the control of robot pairs and other tasks?
I don't understand the question. I didn't hear it. Can you repeat louder?
Louder? Any problem? As I can understand from your slide, you are investigate industrial robots for automate and semi-automate assembly.
Yes, yes.
Yes. Are you using in your research system of technical viewing for the control, the task of robot pass and other question or not?
No, for now, no. But in future we are planning to do more wide, more serious research. It's like for now it's start. It's some question of methodology of it, how to do it, and later, yes, of course, we will do it in this area too.
Thank you very much. This is very interesting direction, and we in our laboratories are working in this direction too. Perhaps in future we'll be connected and
thank you very much.
Our own research. Thank you very much. So the second presentation, Professor Dedura from the Sumy State University, standardization issues in the test methods for engineering nanomaterials. Please, you can start. Professor Dedura, you can start your presentation. Any problem? Professor Dedura, you can start your presentation. You can start your presentation, Professor Dedura.
Okay. Good morning, dear colleagues. You can start.
Please, you can start.
My presentation. It's problem. Okay.
Что-то все исчезло с экрана. Ну, что-то они там настраивают. Ну, нет, это их проблема. У нас Please, Professor Gidula, you can start your presentation.
The topic of my presentation is standardization issues of test methods for engineering nanomaterials. Yes, next slide. Yes. Okay, thank you very much. The presentation relates to the field of standardization of methods for testing by ecotoxicity of engineering nanomaterials using microorganisms. Owing to the expansion of production and use of engineering nanomaterials, society is paying more and more attention to the issue of nanosafety. Today, regulators of the influence of physicochemical parameters of nanoparticles on biological objects and ecosystems are characterized by a high degree of uncertainty. The study of the properties of engineering nanomaterials is crucial for the methodological search for risk assessment and management strategies in the nano industry. The topic of nanosafety in Ukraine should eventually move to another level. Today, we have a situation where the responsibility for the safety of nanomaterials and nanotechnology is the sphere of the scientists involved in their development. Europe went further. Given the Europe approaches, we must change the emphasis. Please, next slide. The aim of our study is to develop a multi-criteria methods for assessing the toxicity of a new nanomaterials of zinc S alginate using the simplest organisms and that are distributed in the environment. Please, next slide. We should work towards state regulation of the safety of nanotechnology for the environment and human health. Working in this direction, the development of standardized methods of ecotoxicity research remains important in the future. They can be the basis of a state regulatory documents in the field of nanosafety. Please, next slide. This organism is Aspergillus niger. Aspergillus niger. Aspergillus niger is a fungus and one of the most common species of the genus Aspergillus. Please, next slide. The definition of environmental toxicity containing various concentration of examined samples was done in experiments with Aspergillus niger which are according to patent. Before the inoculating, the quantity of spores in one drop of the prepared suspension was defined according to the help of Garayev camera. Next slide, please. On this slide, you can see the definition of environmental toxicity. The standard suspension of the Aspergillus niger test culture was obtained in amount of 100 microliter. On the slide, you can see the distribution of test culture Aspergillus niger in the experimental series. Aspergillus niger was inoculated in Sabura agar medium containing various concentration of the tested substance zinc as alginate. Please, next slide. On the slide, you can see the distribution of test culture method for determination. Zinc as alginate was synthesized in the laboratory of banana composite of Sun State University. Previously, its physicochemical parameters were studied. The mineral composition of the synthesized nanomaterial was investigated by X-ray fluorescence analysis with using spectrometer. The morphology of zinc as alginate nanoparticles was studied by transmission electron microscope. Please, next slide. Now we know these nanoparticles have a spherical structure and have antibacterial properties. After, next slide, please. After all this, it was possible to recommend material for surface treatment and protection against pathogenic microorganisms. Aspergillus niger was inoculated on sabur agar medium, contain various concentration. Please, next slide. But we believe that a responsible attitude needs to the study of ecotoxicity. The study of the ecotoxicity of this material is the culture of Aspergillus niger cells has proven the presence of low ecotoxicity. We believe that this technique using the simplest organism is economically possible and express. I'm sorry. Please, next slide. Where did my presentation?
Please, you can continue. Выключите, пожалуйста, будьте любезны. Please continue.
Please, next slide. Number 13. Okay. In addition, we plan to support the result of toxicity. Please, next slide. Next slide, please. Next slide, please. Okay. By using simple aquatic organisms. In modern condition, we consider our approach is promising and scientifically sound. It can really amplify the standardization process in nanosafety. Thank you very much. I finished.
Thank you very much for your report. Please, questions to speaker. I have a question. As I can understand from your slide number 2, aim of research task, you have developed an effective algorithm for multi-criterion decision.
Yes, yes.
But on the slides, scheme of this algorithm I can't find. Can you shortly comment this algorithm? Main task.
Slide number 2. Slide number
Yes.
2. Ah.
My question about algorithm of your research. Which
In the slide, it's actuality, the problem of nanosafety for Ukraine scientists and your and their development. Problem of nanosafety. Problem of nanosafety for Ukraine, for Europe and other country. Nanosafety is actuality for scientists, their development.
Thank you very much. Any question? So, the program of our section has been completed. I thank all the oral speakers for interesting report and wish you great success in your further scientific work. Thank you very much. And next session number
почту?
На почту, да? Я еще не видел. Хорошо, сейчас посмотрю. Спасибо, Виталий.
З картинкою, світлом, все нормально, так?
Так, все добре. Все добре. Скажи ще, будь ласка, щось. Це краще, але є якийсь шум у ефірі. Можливо, це не від вас, а від іншого учасника.
Hello, dear participants of our conference. I'm so pleased to start our session, Interdisciplinary Research. This session was formed due to its topics covers urgent issues of the joint fields in the field of manufacturing engineering, mechanical and chemical engineering. And as you already know, my name is Ivan Pavlenko. I'm I'm a Vice Dean for Research at the Faculty of Technical Systems and Energy Efficient Technologies of Sumy State University and Managing Editor of the Journal of Engineering Sciences. And it's a great honor for me to be session chair within this reputable international conference. And first of all, I would like to express my appreciation to all the participants which will contribute significantly in our conference. And let me say some words about the statistics of our session. This session, named as Interdisciplinary Research, has united 22 researchers from 8 universities of Ukraine and Romania. There are 5 presentations within this interdisciplinary research section in the field of designing of technological equipment. And so the first speech, the first presentation is presented by Igor Dudarev, Serhiy Galyachuk, Yuri Hunko, and Svetlana Panasyuk from Lutsk National Technical University, Ukraine. The topic is modeling of the mixing process in the gravitational mixer using the theory of Markov chains. The abstract of this research is presented on page 56 in the book of abstracts. Please, you have up to 12 minutes for your report and about 3 minutes for the discussion after that. So you have the floor.
Thank you very much, Ivan. Good afternoon to all conference participants. I'm Igor Dudarev, and I, with my colleague from Lutsk National Technical University, present report modeling of the mixing process in gravitational mixer using the theory of Markov chain. The production technology of many food products involves the mixing of the raw materials, semi-finished products, or finished products related to bulk and granular materials to produce a mixture with a given ratio of component. During mixing of components, it is important to ensure the uniform distribution by the volume of the mixture. The mixing process depends on many factors, such as the properties and number of components, the particle size and proportion of components in the mixture, the design of mixture, and the way the components are loaded. The next, please, slide. In the food industry, the mixes of various types are used to the mix bulk materials. The most common are batch drum mixes. Most batch drum mixes are equipped with special working bodies that provide intensive mixing of the mixture component, which is unacceptable for individual materials because they lose their properties. Also, drum mixes have a low degree of filling the volume of the working chamber and, as a rule, periodic action. Respectively, the consumption of time for loading and unloading the mixture reduces its productivity. Among the known mixer design, gravitational mixes without moving working bodies have the lowest energy cost. The next slide, please. So the research aim was to simulate the mixing process of bulk materials in proposed gravitational mixer using the Markov chain theory and justify the mixer design parameters. To achieve the research aim, it is necessary to develop gravitational mixer, which should be continuous and should not contain active working bodies. Study components flow in the mixer with simulation of mixing process and verify experimentally the applicability of the mathematical model of the mixing process. Next slide, please. Experimental study was conducted on the proposed gravitational mixer, which consists of sections of the same design installed one above the other. The section is formed by the body, inside which two vertical partitions are fixed. From the operation parts of the section, the combine and the separate are attached to each vertical partition. Each combine and separate is formed by two plates. The next slide, please. The experimental study of the mixing process in proposed mixture was carried out on candy dragées of four colors: yellow, green, blue, and red. Candy dragées were indicate yellow component A, green component B, blue component C, and red component D. The components were mixed in the ratio of 1 to 1 to 1 to 1. The ratio study was carried out in the gravitational mixer with 5 and 7 sections. 4 flows of the mixture were sent to 4 containers after mixing process in the mixture. The mixture from each container was divided into components A, B, C, and D, and the number of each component in the mixture was determined. The next slide, please. So the average number of components in the mixture, the average content of components in percentage, and the quality index of the mixture were calculated separately from each container. Also, the distribution of each component in all containers were determined. Each container corresponds to the certain state S of the mathematical model of the mixing process. Also, the damage of candy dragées is determined organically after mixing. The next slide, please. The mixing process is very difficult to simulate because it depends on many factors. Most models of the mixing process are designed to describe the mixing of the two components. Development of models requires a study of the component flow in the mixture. Modeling of the mixing process was carried out using the mathematical equations that describe the Markov random process, which discrete state and time. The modeling was carried out on the assumption that during the fall of the particle of bulk material A from the plate of the combine, 3 cases of its motion possible. The first case, the particle of the bulk material does not fly through the plane V and it does not contact with the particle of another bulk material B. It is scheme A. The second case, the particle of bulk material A does not fly through the plane V as a result of contact with the particle of other bulk material B. It changes the trajectory. It is scheme B. And the third case, the particle of bulk materials A flies through the plane V in scheme C. Each of these cases of movement of the particles A due to a number of factors. the properties of bulk materials that are mixed, interaction of the particle of different bulk materials. Also in the studies, it was assumed that all three cases of motion of the particle of bulk materials A are equally probable. The probability that particle of bulk material A does not fly through the plane V is 0.66, and the probability that the particle of bulk material A will fly through the plane V is 0.33. A similar assumption can be made for the particle of bulk material B. The next slide, please. The graph in the slide presents the motion of flows of component A, B, C, and D and their mixtures in the proposed gravitational mixer. In each of the four initial flows of the component, they are fed to the top section of the mixer. The single particle, dragée, is selected, and probability of the staying this particle on the plates of the separates of each mixture section is determined. The location of the component particle on the plate of the mixer separates are named state S. Each plate on the separate of all mixer section and the plate of the combiners of the top section of the gravitational mixer correspond to the state S of the component particles. All state S of the particles of components are numbered as shown in the graph. Possible transition of the component particle from the state to state in the graph are marked by arrows. The probability of the particle transition from the state to state is denoted by capital letter P. If individual transitions are impossible, that their probabilities are zero. The probability of state of the component particle after stage K can be calculated by equation 1. Next slide, please. The slide 10 presents the result of experimental studies of the mixing process of candy dragée of 4 colors in the gravitational mixer containing 5 and 7 sections. The diagram A shows the average number of components in the mixture from 4 containers after mixing in 5 sections, and the diagram B shows the average number of the components in the mixture from 4 containers after mixing in 7 sections. Next slide, please. Analysis of mixtures from 4 containers after mixing the component in 5 sections indicates that the average content of component in the mixture varies widely. Diagram A. For component A from 19.5 to 29.4%, for component B from 20.5 to 28.5%, for component C from 20.5 to 30.2%, and for component D from 21.1 to 30.3%. Such a significant difference between the average content of component in the mixtures from different containers indicate a lack of component mixing in the 5 mixer section. Analysis of mixture from a container after component mixing in 7 sections indicates that average content of components in the mixture are range is diagram B. For component A from 23.8 to 26.1%, for component B from 24.2 to 25.3%, for component C from 22 to 27%, and for component D from 23.4 to 26.8%. This difference between the average content of component in the mixtures from different containers indicate a good degree of mixing. The next slide, please. For the case of 5 sections, is diagram A, the quality index of the mixture for each component is range for component A from 7.2 to 22%, for component B from 6 to 18%, for component C from 12 to 20.8%, for component D from 6.4 to 21.2%. The quality index of the mixture indicates the poor quality of the mixture after component mixing in the 5 mixer sections, so the 5 sections of a gravitational mixer are not enough to get a good quality of the mixture. For the case of 7 section, diagram B, the quality index of the mixture for each component range for component A from 2.4 to 4.8, for component B from 0.8 to 3.2, for component C from 0.4 to 8%, and for component D from 4.4 to 7.2%. The following values of the quality of the mixture indicate the good quality of the mixture of the components mixing in the 7 mixer section. According to the content of component A and B, the quality of the mixture is excellent. The candy dragées inspection after mixing in the gravitational mixer showed that the dragées surface were not damaged and cracked. The next slide, please. The study of the distribution of each component in the 4 flows of the mixture, which come out of the 5th and 7th section of the gravitational mixer, shows that experimental values of the content of each component in the container do not differ significantly from the probable content of this component in the containers, as determined by the modeling of the mixing process. The next slide, please. So, among all components, the largest differences between the experimental and model data is for component B in the mixture from the container, which correspond to the state S22. In the case of 5 sections, the experimental content of the component is 26%, and the probable content of this component obtained from the modeling is 28.8%. In the case of 7 sections, the experimental content of component A in the state S32 is 23.4%, and the probable content of this component obtained from the modeling is 25.6%. So the model of mixing process accurately describes the process of 4 bulk material mixing in the gravitational mixer. The next, please, slide. So the main conclusion of the study are the proposed design of the gravitational mixer has the advantages. The mixer does not contain active working bodies, so the components are not damaged. In the mixture, there are no energy cost for mixing process. The mixer is compact and easy to maintain. The second, modeling of the mixing process in gravitational mixer using Markov chains theory can be used to describe mathematically the component flows in the mixture section and to determine the probable content of each component in the mixture and each stage of the mixing. Also, the number of mixer sections can be determined by a proposed mathematical model of the mixing process. Such mixer sections should be not less than 7. Candid Roger mixing in the mixer containing 7 sections provide a good quality of the mixture, since the quality index of the mixture is a range from 0.4 to 8%. And that's all. Thank you very much for your attention.
Thank you very much. Thank you, Igor, for your report. Does anybody have questions? If there are no questions, I have one. Please clarify, what is the main difference between the simulation results of the mixing process carried out using the Markov chains and traditional ones of the analysis of mixtures? Have you compared the results?
Yes, thank you very much for your question. The main difference between the experimental data and the modeling data is about 10%.
Thank you. Thank you for your answer. If there are no questions, let me introduce the second speaker. The speaker is Galina Kabalava. She is a specialist in designing aerothermal compressors. And the next speech is presented by the specialist and the topic from Christian Scurtu from Naval Academy Romania and Admiral Makarov, National University of Shipbuilding, Ukraine. And now you're welcome.
Yes, thank you. Hello, everyone. I'm Galina Kabalava. I work at Admiral Makarov National University of Shipbuilding at the Department of Thermal Engineering. And now I'm going to present you our team research, which dedicated to define the optimal sizing of the evaporation chamber in the low flow aerothermopressor for a combustion engine. So let's start. Next slide, please. Okay. As we know, gas turbine plants are widely used to power aircraft, ships, electrical generators, pumps, and others. Complex cycles, so with cyclic air intercooling by using an aerothermopressor. As you can see, the apparatus is installed between the compressor stages. In this scheme, the aerothermopressor is used for contact cooling of cyclic air. The thermopressor, scheme of which is presented on the right side, is a two-phase jet apparatus in which the air pressure and air cooling are increased by removing heat from the airflow with the proper organization of the operative contact cooling process. The effect of thermogas dynamic is taking place. The next slide, please. Okay, there are a number of design and technological factors affecting the apparatus efficiency, such as flow design and method of injected water in the apparatus, the aerodynamic resistance influence of the injection system, but this research is dedicated to define the optimal relative lengths of the thermopressor operation chamber for obtaining the maximum value pressure increase as a result of thermogas dynamic compression. Next slide, please. Okay, simulation of water evaporation process in the thermopressor operation chamber was carried out by using computer CFD modeling techniques. Eulerian Lagrangian model was used to compute the two-phase flow. There is as a continuous phase and water droplets at the dispersed phase. The calculation of the two-phase flow is carried out in the following order. First of all, we calculated the discrete phase in Lagrangian approach based on the calculated air field. Then after that, we calculated the discrete phase in Lagrangian approach based on the calculated air field. On the basis of the data obtained, the analytical equation was determined to define the optimal relative lengths of the thermopressor operation chamber. And finally, we simulated the thermopressor operation taking into account the optimal lengths of the evaporation chamber. Move to the next slide, please. Okay. The thermopressor model and the evaporation chamber are shown on the left side. The main size of the chamber with a diameter of 50 millimeters was adopted, at which the air must flow from 1 to 1.5 kilogram per second. The chamber length was optimal to determining the maxima of the pressure increase. The parameters of the airflow at the inlet, such as velocity, temperature, mass flow, pressure, correspond to the parameters of the cyclic air between the compressor of the stage. Water droplets were taken spherical shape and were injected in the same direction as flow. Next slide, please. Okay, to define characteristic of the thermopressor workflow, the developed software was used. It is based on calculating thermogas dynamic compression methods. A feature of this effect is an increase in pressure as a result of instantaneous evaporation of injected into the airflow accelerated to the speed of sound. Pressure losses due to the aerodynamic resistance of the two-phase flow in the thermopressor flow but were included. Next slide. Analyzing results. As a result of computer simulations, the values of the main characteristics of the evaporation process were obtained. Changes in pressure and flow temperature are shown for the evaporation process of water with a droplet diameter of 6 microns. The evaporation process of water and the droplet's trajectory are also shown. Next slide, please. Analyzing the data obtained by numerical simulation of water evaporation process in the thermopressor operation chamber, maxima of the increase in pressure were obtained. The results demonstrate the maximum pressure increase value shifts to the left at droplet diameter 3 microns, while the pressure is 336 kilopascal. Relative length of the section with water evaporation is 408 depending on the inlet air temperature, with a droplet diameter increase to 7 microns. Relative length of the section with incomplete water evaporation increases more than 5 times. The evaporation rate depends on the initial droplet's diameter of injected water, and better spray will lead to the more efficient evaporation process. Next slide, please. Continue with the next slide. You can see the depths of thank you. You can see the depths of humidified air cooling on the evaporation chamber outlet is 70 degrees at the inlet temperature 400 Kelvin and 150 degrees at the inlet temperature 500 Kelvin. The amount of injected water in their flow to 6%. Next slide. Next slide. Okay. The change in the droplet diameter along the evaporation chamber length is shown in the figure on the left side. For low flow air thermopressor with air mass flow to 1.5 kilogram per second with an initial droplet diameter from 7 to 20 microns, there is no full evaporation of water droplets. A three-dimensional surface was constructed that takes into account the initial droplet diameter and water mass concentration on the length of the evaporation chamber at maximum pressure increase. We got the question to define the optimal relative length of the evaporation chamber. It is presented at the bottom right. Next slide, please. Okay. The air thermopressor operation as part of the gas turbine was simulated. The apparatus was used for contact cooling of cyclic air between low and high pressure compressor stages. Depending on Mach number and the initial water droplet diameter, the pressure increase degree rises from 7 to 10% with a droplet diameter of 18 microns and from 10 to 13% with a water droplet diameter of 3 microns. That is with an increase in the inlet air temperature by 100 degrees. The evaporation chamber length decreases by 25%, an increase in droplet diameter from 3 to 18 microns. The evaporation chamber length increases by 20 times. Next slide, please. So, conclusions. The main of which is that we obtained a question to define the optimal relative length of the air thermopressor evaporation chamber. It allows to determining the rational length of the evaporation chamber, which corresponds to the maximum increase in pressure. This equation can be applied in the low flow air thermopressor design and at the mass flow from 1 to 1.5 kilogram per second. The air thermopressor design parameters were obtained for the gas turbine cooling system. In this case, the maximum pressure increase to 13% corresponds to the lowest initial droplet diameter, with the relative length of the evaporation chamber equal to 1 at the inlet air temperature to 500 Kelvin. So my presentation has finished, and thank you for your attention. Maybe you have any question for me.
So thank you, Halina, for your report. Does anybody have questions, please? There are no questions, so please ask me what kind of limitations, maybe simplification or boundary condition did you use for modeling the operating process? And did they allow to provide the reliable results?
We took, you may, it's inlet conditions.
Maybe.
Yeah?
Maybe this one.
We took inlet temperature, inlet pressure, and inlet initial droplet diameter for injected water, and simulate the process of evaporation of evaporation in the CFD program like Fluent.
Thank you. Thank you for your answer. Thank you.
Okay, thank you.
Thank you for your report. And the next presentation, engineering methodology for determining elastic displacement of the joint spindle assembly face milling cutter while machining planes, is presented by Georgy Vygovsky, Mykola Plesak, Natalia Balitska, Alexander Melnik, and Larisa Glembowska from Zhytomyr Polytechnic State University from Ukraine. This research is presented in page 70 of the Book of Abstracts. The speaker is Mykola Plesak. He's a specialist in designing and modeling of particularly of machining process. And please start your report.
Good afternoon, everybody. Thank you for the introduction. How can you hear me? Good? Yes? Okay. My name is Mykola Plesak, and I am postgraduate student at the second year of study at the Zhytomyr Polytechnic State University. I would like to say thank you for this conference. The technical organization is very good. Thank you for the invitation. I'm really happy to take part in this conference. And let's start. I will be represent this paper on the topic engineering methodology for determine elastic displacement of the joint spindle assembly face mill cutter while machine planes. Next slide, please. The purpose of this work is to develop engineering methodology for the simplifying determination of elastic displacement of the connection spindle unit and cutting tool while machine planes. Research task to develop 3D model, spindle unit, cutting tool, and set up contact set for the static analysis. Determine the stiffness characteristic perpendicular XZ axis and along the axis Y. Determine the axial displacement value of the cutter insert and in the cutting process. And the last one, calculate maximum flatness division of the workpieces as results axial displacement of the cutter insert. Next one, please. On this slide, you can see 3D model, spindle unit with cutting tool. The spindle consists with position one is face mill, position 2 spindle housing, position 3 is spindle, position 4 is double row cylindrical roller bearing, position 5 is gear, position 6 is double row angular contact ball bearing, position 7 is double row cylindrical roller bearing. Next slide, please. On this slide, you can see a contact date, a cutting date. The calculation was performed for a vertical milling machine with a fixed face mill in the servo simulation for 2 different cases, like finishing of cast iron and for roughing of high temperature corrosion resistant steel. Next slide, please. On this slide, show radial force value, which are action on the bearing inner rings. You can see in the table 1. These values for 2 processed material. First one is cast iron, and the next one is high temperature corrosion resistant steel. Next slide, please. On this slide, you can see double row angular contact ball bearing, which show in the figure 2, and consist with position 3 is out ring, position 4 is inner ring, position 5 is both. After that, model was a little bit simplified in some places, as you see in the figure 3. position 1 on the bearing ring and position 2 on the bearing balls. We create allocated faces for localization contact. Next step was create boundary condition, no penetration and friction between balls and rings. Use allocated faces and apply radial force value, which are action on the bearing inner rings in the radial and axial direction. Next slide, please. After the calculation was used equation, which show on this slide for the determine radial and axial stiffness of the bearing. The values you can see in the table 2 for 2 cases like cast iron and high temperature corrosion resistant steel, and for 3 different bearings. Next slide, please. No, last one. Yes, thank you. On this slide, you can see spindle uni, which little bit was simplified as hide some parts like gear, spindle housing, bearing, and we create 3 sensors, which show in the figure 4, position 1, 2, 3, for the determine elastic displacement of the spindle. After that, we set up boundary condition, like no penetration and friction between the parts which contacting with spindle, and was used connection bearing. After the calculation, you can see on the figure 5 values displacement of the spindle relative to axis in the radial direction for the 2 processed material like cast iron and high temperature corrosion resistant steel. And next slide, please. And the next step was determine the elastic displacement of the cutter insert. Values for the cast iron is 0.04 millimeters, and high temperature corrosion resistant steel is 0.3 millimeters. And determine angle of the face mill relative to axis of the spindle. For the values for the cast iron is 0.01 degree, and high temperature corrosion resistant steel is 0.08 degree. And maximum flatness division values for cast iron 0.050 millimeters, and for high temperature corrosion resistant steel is 0.14 millimeters. Next slide, please. And conclusions. These articles represent the engineering methodology for static calculation of the joint of the vertical milling machine, spindle assembly with a milling cutter in the SolidWorks simulation environment to determine the elastic displacement. The maximum flatness division of the machined surface of the workpiece with a weight of 350 millimeters were determined for symmetric machining of the face milling cutter, and diameter 440 millimeters, namely 0.050 millimeters at the finishing process of cast iron, and 0.40 millimeters at the roughing processing of high temperature corrosion resistant steel. The developed methodology can be used to analyze and predict the influence of the connection design between machine, spindle, assembly, and tools on the geometric accuracy of machining flat surface. This will reduce the number of costly full cases test. Thank you. Next slide, please. Thank you for your attention. I'm ready for the questions.
Thank you, Mykola, for interesting speech. Does anybody have questions? Okay, I have one question. I really know how it's difficult to model the contact interaction between elements of ball bearings, particularly in the field of modeling dynamics of rotors and other machines. And so please let us know, did you use special types of contacts? Because in general case, there are problems with the stability of ball's positions while loading. Or maybe you have used the ordinary approach without additional conditions because it was static loading.
Thank you for your question. When I was calculated, I used allocated phases. It helped me to calculate it because when I try calculate it without allocated phases, I have some problem with this because model doesn't want to work, and only allocated phases help me to calculate it. I use between balls and rings, inner and out rings, contact no penetration, and friction only on these allocation phases. So,
Okay, thank you for your answer, and thank you. And now we have the next presentation. The fourth presentation, high-octane fuel compositions based on petroleum and biocomponents, by the authors Nina Mareshka from Kyiv National University of Trade and Economics, Valentina Tkachuk, Oksana Rechun, and Viktor Zaharuika from the Lutsk National Technical University, and Victoria Romanchuk from the National University Lviv Polytechnic, Ukraine. And the speaker is Valentina Tkachuk. She is a specialist in fuels. Please, your floor.
Good afternoon, dear colleagues. I am Valentina Tkachuk. I am Associate Professor of Commodity Research and Expertise in Customs Affairs Department. And today I'm glad to represent Lutsk National Technical University. The theme of my report is high octaneous fuel compositions based on petroleum and biocomponents. Please show slide 1. The problem of environmental safety of road transport has become part of the security of Ukraine. The annual increase in emissions of auto transport into the atmosphere requires stricter environmental requirements for commercial vehicles and exhaust gases of internal combustion engines. World experience shows that the use of 10–15% bioadditives in a gasoline mixture does not have a negative impact on the technical and operational performance of the internal combustion engine. In addition, there are more advantages in using the type of fuel since it is an environmentally friendly type of fuel and it generates fewer emissions during combustion. Biofuels can be adapted to existing engine designs that will be well used in all conditions. At the same time, this fuel is better for engines. It reduces the overall cost of controlling engine pollution and consequently its use requires less maintenance costs. At the same time, modern requirements for gasoline consist in the fact that they must ensure the creation of homogeneous fuel-air mixture of the necessary composition under any temperature conditions. This article investigates the production of high-octane gasoline A92 and A95 by using high-octane applications. Next slide, please. Purpose of the work is to obtain high-octane gasoline A92 and A95 by using high-octane applications. The object of research. The following bioadditives were used in the studies: methyl terbutyl ester, MTBE, ethanol, and isobutanol. As a basis for gasoline, catalytic cracking gasoline, catalytic reformate, benzene production raffinate, straight-run gasoline, and petroleum solvent were used. These are products that are manufactured at a modern oil refinery and are available on the market for oil products. Next slide. At the first stage of research, the basic basis of gasoline A92 and A95 were obtained by mixing oil components: catalytic cracking gasoline, catalytic reformate, raffinate gasoline production, and oil solvent in such a ratio to as to provide an octane number in the mixture of about 90 for gasoline A92 and 93 for gasoline A95. As a result, the basic bases of gasoline A92 and gasoline A95 were obtained. In them, octane numbers were determined using the Morter method and the research methods according to the methodology described in the ISO 5164-2005 as STU. At the second stage, the influence of bio-applications on the change in the octane number of the base gasoline base was determined. To do this, bioavailabilities were added to the basic bases in the amount of 5, 7, and 9% by volume each. In each mixture, the octane number was determined by Morter and test method according to SSTU ISO 5164-2005. Based on the data obtained, we recommend the formulation for obtaining A92 and A95 gasoline with bioadditives. In these gasolines, the octane number was determined by experimental method densities, sulfur content, aromatic hydrocarbons content, fractional composition, benzene and oxygen particles, concentration of actual resins, and the data were tested for compliance with the requirements of DSTU 7687-2015. All these indicators were determined by standard methods. Next slide, please. The composition of the basic basis for obtaining gasoline A92 and A95, which are used to study the impact of bioadditives, are presented in Table 1. Next slide. In the course of research, the influence of applications on the octane characteristics of the base of gasoline A92 and gasoline A95 was established. Look Table 2. The octane number was determined using the Morter method and the experimental method. Next slide. From the above data, it can be seen that the largest increase in the octane number is given by adding ethanol in an amount of 10% for gasoline A92 and A95, to a lesser extent MTBE, and even less isobutanol. However, taking into account the cost of ethanol, which is currently 35,000 hryvnia per ton, and the cost of isobutanol 26,000 hryvnia per ton, to reduce the cost of gasoline, we recommend isobutanol as a high-octane addition to gasoline. In addition, to reduce the amount of aromatic hydrocarbons in gasoline, it is recommended to reduce the content of catalytic cracking gasoline in gasoline A92 from 53 to 30%. Leave the content of catalytic reformant at the level of 35% and reduce the refined gasoline production from 12 to 10%. For A95 gasoline, the content of catalytic reformant should be reduced from 44 to 37% and catalytic cracking gasoline from 50 to 28%. Since each refinery has a fraction of straight-run gasoline of 85 degrees Celsius, with a low cracking gasoline from with a low octane number, it is advisable to add it to gasoline. In our case, it is added in an amount of 10% to the A92 gasoline and 9% to the A95. It should be noted that methyl butyl ether belongs to the hazard class 4, and it's used by us that MTBE has a low soil accumulation capacities, and it found in the soil only at high concentrations and partly migrates into air due to its high volatility. The amount of isobutanol that is added in an amount of 10%. To increase the octane number of gasoline A92, we recommend adding MTBE in an amount of 5% as a component with the highest octane number for gasoline A95 in an amount of 9%. In addition, For high-octane gasoline, A95 is given as a solvent as a high-octane component in an amount of 5%. Next slide, please. The recommended formulation and characteristics of the obtained A92 and A95 gasolines are presented in tables 3 and 4. The indicators of the obtained gasolines presented in these tables are obtained by the calculation method. The composition of gasoline is selected in such a way as to obtain gasoline with an octane number of 92, while the content of aromatic hydrocarbons in the resulting gasoline should not exceed 35%. As in the A92 version of gasoline, the gasoline composition was selected so that its octane number was close to 95, and the content of aromatic hydrocarbons did not exceed 35. Next slide. The resultant mixtures were analyzed in the laboratory for compliance for all quality indicators with the requirements of state standard of technical conditions 7687 per column 2015. Comparative data are presented in Table 5. Analyzing the data in Table 5, it is established that the gasoline with an oil base and with the addition of bioadditives meet the requirements of state standard of technical conditions 7687 per column 2015. And last slide, the influence of bioadditives, ethanol, isobutanol, MTBE on the increase of octane number of gasoline prepared base on gasoline catalytic cracking, reform of catalytic reforming, benzene production refinement, solvent and straight-run gasoline is investigated. An optimal formulation of gasoline has been developed with the use of all refinery components and high-octane bioadditives. The largest increase in octane is found to be the addition of 10% ethanol for gasoline A92 and A95 to a lesser extent MTBE in less isobutanol. However, given the cost of ethanol, to reduce the cost of gasoline, we recommend adding isobutanol as a high co-octane additive to gasoline. To increase the octane number of gasoline A92, we recommend the addition of MTBE in the amount of 5% as the component with the highest octane for gasoline A95 in the amount of 9%. In addition, solvent for high-octane A95 gasoline is added as a high-octane component in the amount of 5%. The result of these studies is to establish the optimal ratio of components in fuels which are different from the existing counterparts of the new recipe obtained from oil refining water to obtain a composition that meets the Euro 5 gasoline standard in terms of octane number, aromatic hydrocarbon content, benzene content, sulfur content, fractional composition, concentration of active resins, and would not be corrosive. The indicators of refined gasoline meet all the regulatory requirements for high-octane gasoline A95, Euro 5 according to the state standards of technical conditions requirement 7687 per column 2015. Thank you for your attention.
Thank you, Valentina, for interesting report. And so I see one question. Can you clarify what are the main practical recommendations to obtain the required properties of petrols of two models?
The result of our studies is to establish the optimal ratio of components in fuels, and it will be economic and ecological have advantages. So it's the main purpose of our work.
Okay, thank you for your answer. And now we have the last presentation within our session, number 6. This presentation is presented by the authors from Karazin Kharkiv National University and the National Technical University Kharkiv Polytechnic Institute from Ukraine, Valery Khodusov, Oleg Pignasty, and Georgy Kazhevnikov. Title of this yes is the dynamic model on conveyor belt stress, and the speaker is Georgy Kazhevnikov. He is a specialist in the field of automated transport systems. We hear you. You're welcome.
My name is Georgy Kazhevnikov. I'm from Kharkiv National University, Kharkiv Polytechnical Institute. We are grateful to organize the conference for the opportunity to present our results at such prestigious scientific forum. And now let me present you all the please next slide. Please give me next slide. I can see it. Let's see. The characteristics of Industry 4 is fully automated production. The conveyor belt is an integral part of an intelligent industrial automation system. Smart modern factories create transport systems that can improve the efficiency of production process control. The conveyor is a link between the production modules. Belt conveyor are one of the main modes of continuous transport in mining enterprises. Today, on these enterprises, complex transport systems are formed of conveyors. The length of modern conveyor exceeded 100 kilometers and continues to increase. They connect countries through borders. You can see it left picture. And this conveyor across the distance. You can see it very powerful picture. Yes, you can see the conveyor across the distance. Next slide, please. To increase reliability, next slide, please. No. Previous slide, please. To increase reliability, the transport road is divided into sections. The technology supporting material provides a section length of up to 20 kilometers. Operations are present in this table. Throughout control of the conveyor transport system is reduced to controlling the intensity of the material at the input of the conveyor sections or to control the speed of the conveyor belt. Dividing the transport road into sections allow providing the transport system a different speed of conveyor belt for each also control algorithm for the separate section. I control system, please next slide. When designing a control system for flow parameters of conveyor online, the limitations should be taken into account. The specific linear density of the material which is located on the conveyor belt is limited by the maximum value. Absence of consideration of this factor leads to the disruption of continuous operations of the conveyor online. As a result, the conveyor belt rupture. You can see this experience on this picture. Next slide, please. The feature of transport systems used in the flow of entering the transport system in non-stationary This leads to an uneven distribution of material on the belt along the transport road. To ensure a uniform distribution of material on the conveyor belt, the speed control of the conveyor belt is applied inside the separate sections. A change in speed leads to the fact that the belt begins to move with accelerations or decelerations. As a result, stresses along the belt, the value of which is higher than maximum allowable ones, which leads to the destruction of the belt. To prevent this, additional restrictions will be imposed on the algorithms for controlling pipeline flow parameters. However, limitations are usually not taken into account when designing a speed control system algorithms. They are extremely necessary in case of uneven loading of material along the road. To solve this problem, we offer an analytical model of conveyor taking into account the uneven distribution of material. Please, next slide. For designing control conveyor line, two main types of models are used. The first type is distributed model. One of the distributed models of a single conveyor are based on the finite element method. The mode allows to determine the line and material as the length of the conveyor increases, the number of operations increases too. It may be over 3,000. The time of solving the task target conveyor control. This next slide. The second type is the aggregated models. The model is used for estimated calculations of conveyor lines. The model doesn't give an exact solution and can be applied control system of conveyor line under extreme load and non-stationary loads. Next slide, please. Please give me a next slide. Thank you. Another type of production is kind of flow production. An important feature of electrical conveyor is that the material of the belt I don't know what is maybe algorithm it's a very simple form and can be solved analytically. On this slide, you see the equation for the moment or elementary section of the conveyor. The material located on the conveyor belt and distributed along the here the bottom TF. The conveyor length is SD. The scheme of forces acting on the elementary segment of conveyor is shown on this picture. Please give me the next slide. Thank you. The total resistance movement is equal sum of four resistance. Primary resistance F(H), the force Fn taking into account the effect of secondary resistance. The force F as characterizing the gradient resistance of the belt and the transport material. In this case, we must take into account characteristics of conveyor belts. Please, next slide. The construction of general purpose conveyor belts and its characteristics, which we must take into account in this model, are shown on this slide. Please, next slide. For For the model and the consideration, we must take into account the relative deformation of the element of the conveyor belt. We believe the stresses and strain are related by a linear relationship. E is the modulus of elasticity. Epsilon is frictional extension of the element belt, which depend on the characteristics of the belt discussed on the previous slide. The related deformation of the element of the belt is equal to the ratio of the elongation of the element to the length of the segment. This next slide. The system of equations for the STEI that determine the movement of the belt at the characteristic points of horizontal conveyor sections is shown on this slide. FC is coefficient resistance to movement, includes from resistance of driving force and belt intentional resistance. Sigma C is the inclination angle of the conveyor. C0R is the linear loading from rotating path determined by the ratio of the mass of the rotating element roller M and the distance SR between the axes of rotating element. Please, next slide. The speed of conveyor belt consists of the speed of the belt in the steady motion and the vibration part of speed. The part of the speed represented by partial differential equations. The function C from TC determines the propagation speed of disturbance along the. Please, next slide. The resistance calculations value of dynamic stresses arising in the conveyor belt are shown on this slide. Calculations are performed in relative units. Conveyor belt length varies from 0 to 1. Calculations are performed in relative units. Each of the lines shows the stress value along the conveyor belt at different times. The upper part of the graph shows the stretching of the belt along the conveyor from 0 to 0.12 seconds. The lower part of the graph shows the compression of the belt along the conveyor at the times from 0.2 to 0.5 seconds. We can see that the largest stretching of the belt at time 0.06 and the largest compression at time 0.20. This value don't exceed the maximum tolerable value. Please, next slide. The model of dynamic stresses arising during the movement of conveyor belt is a load proposed in the paper. Hooker's was developed using Hooker's law. When the deformation of an elastic object material is proportional to the stress applied to it, the peculiarity of this model is that it allows you to take into account the influence of uneven distribution of material along the transport route of the propagation of emerging dynamic stresses in the conveyor belt. The mechanism of occurrence of dynamic perturbations during the acceleration of the conveyor belt is considered in detail. It's shown that when starting a conveyor belt with linear acceleration, dynamic stresses occur that can cause the destruction of the belt. The prospect of further research is the development of optimal algorithm for controlling the acceleration and deceleration of wheel. Next slide, please. We are grateful to our organizer. And next slide, please. Thank you for attention.
Okay, thank you, Georgi, for your results, for your speech.
Please write me a question because I have a problem with sound.
Okay. We have one question. What results do you expect to obtain in your further research you have declared in conclusions? Please, some words about your further research. Maybe. Okay, we will see Nia soon. So thank you for your attention.
Please write me a question.
Okay, there are no questions. There are no questions, and it was the last presentation. And I really hope the results of the research presented will be impactful for increase the reliability of the technological equipment in a global competitive market. And finally, I'd like to say thanks to all our speakers for their well-presented reports. And so, dear Mr. Chairman, Professor Volodymyr Tonkanogy, thank you for the possibility to conduct this session. Thank you. See you.
Thank you, Ivan. Our conference has come to an end. During 2 working days, scientists from Slovak Republic, Poland, Czech Republic, and Ukraine have actively participated in the discussions. The presentations within machining processes, manufacturing technology, production planning, advanced materials, quality assurance, and interdisciplinary research areas were topical and urgent. Thank you very much to all speakers and the session chairs. To sum up, there are 5 keynote presentations, 21 oral presentations in 6 sessions were delivered, 58 poster presentations were published online. The link will be sent to all participants. The full papers will be published in lecture notes in mechanical engineering and indexed in Scopus approximately in October 2020. I'm very grateful to the keynote speakers for their informative reports. Special thanks to Sumy State University for the opportunity to hold an online conference at a high technical level using the high-tech equipment of the university. And also a huge gratitude to the InterPartner team for their great work. I'm sure that in 2021 we will definitely meet in Odessa for InterPartner 2021 face-to-face and continue the traditions of our conference. Thank you very much. Good luck. See you next year.